Good afternoon. My name is Sean Price, and I work with AirCheck Incorporated in North Carolina, and we're the world's largest radon testing laboratory. We have put together a group of detectors in response to all of the recent news articles and buzz about radon emissions in granite countertops, as well as the gamma radiation that's coming out of the granite countertops. I want to put a little bit of emphasis on what we're seeing on the video and how that might be misleading you, and help to educate you a little bit more on the real concerns that you may have for the granite countertops in your home. We've put together a collection of various gamma radiation measurement tools, traditionally known as Geiger counters. We have one that we found for about $150 on eBay. You push down the button, and then you have to watch the needle. It's got a Geiger Mueller tube, and so you can watch the needle there. Same technology with the Geiger Mueller tube in the end, simply is an improvement because you don't have to watch the needle bouncing around. You can just get the direct readout off the display. This one sells for about $400. This $800 version is the same detector with an external probe, this pancake probe, which is also a Geiger Mueller tube inside. I'm hooked to this, and you can hook different types of attachments to that. These are first responder units. They were very popular during the Cold War. In the event of a nuclear disaster, these were designed to go out and measure very high gamma radiation areas. This unit has the same detector as the more modern digital units that I've already shown to you. This unit is about $10,000. The unique feature that it has is a special detector inside, CZT, cadmium zinc telluride, which helps to identify some of the radioactive minerals inside the granite. Ludlum 19 is several $1,000s. It has the detector mounted on the inside of the box, roughly here where the circle is drawn. It's a sodium iodide detector, and it has an analog readout. This unit has a special plastic detector on the inside that's different from all of the other monitors because it was designed to respond to the gamma radiation the same way that human tissue responds. So this unit actually tells us more about the human dose than any of the other instruments that we have here on display. You'll notice that the units are measuring very close to one another in microar per hour. This one's measuring at 206, roughly 210. This one's about 220. If I hold the button down here, I'm somewhere between 100 and 300, and it looks like it's, right around 200. Which is similar. The Ludlum 19 is measuring about 220. Unlike the other instruments, this one does not over-respond due to the presence of multiple gamma sources inside the granite. This one was designed to measure the total gamma dose to the human body. So this one works best when it is measuring many types of gamma radiations at one time. And when I say many different types, we've got potassium in the slab, we've got uranium, we've got thorium, and we've got a lot of the radon that is trapped inside of the granite and the radon decay products. All of those minerals are emitting gamma radiation. And because the energies are so different, it's basically confusing most of the monitors that we have here. The only one that sees the dose properly is the Bicron micro-rim meter. The probe, when used without its plastic cover, also measures beta radiation. So now not only is it picking up the original gammas, it's reading more gammas because it's closer than we had it earlier, but it's also measuring beta, and those beta particles are also adding to the counts that again help the dramatic effects of the videos. By touching the probe, I put it down in a slightly different spot. So this gives you an idea that there are only certain hot spots on this piece of granite. The whole piece of granite does not have the same amount of gammas coming out of it. By taking the probe, putting the plastic cover back on, the numbers will begin to decrease. On a true dose meter, the detector isn't directly on the surface. It's suspended up inside of the unit. So if we take the probe away a little bit more, we increase the distance from the surface, the numbers begin to fall. So to summarize what I've covered so far, the use of the less expensive, easy to find Geiger counters over-respond quite a bit when placed on the surface, and when they're raised up even to mimic the distance from the granite of the true dose meter, only the true dose meter can measure the gamma radiations in a way that would mimic the effects on the human body. With this second piece of Niagara gold, you'll notice that our detector is hardly registering anything above background. Background in this room has been about 10 microrem per hour, and that's about what we're measuring with this one. So not all Niagara gold is as hot as the one used in some of the television demonstrations. Okay, what have we learned? We've learned that there are many ways of measuring gamma radiation, some more accurate than others. We've also learned that a lot of the granites are emitting very inconsistent amounts of gamma radiation off of the same slab. We've tested approximately 20 or 25 different types of granites from all around the world. This one is the only one that has given us any significant amount of gamma radiation on any of our meters. We also covered the over-response of these detectors in trying to measure the gamma radiation coming out of the granite. And the reason for that is there are small traces of uranium, radium, thorium, potassium similar to the salt substitutes that are emitting both betas and gammas. We've also got radon gas trapped inside the granite block. This is a solid piece of granite. Granites that are sealed, polished, have very limited radon seeping out of it. A lot of the radon is locked on the inside. Once radon decays into its decay products, into its daughter products, they are also emitting gammas. So we've got many sources of gammas inside of the block. And unfortunately, very, very few instruments have the capability of telling you what is coming out of the granite. It just tells you how much, but it doesn't tell you how much of what. So in conclusion, if you want to know how much radon is entering your home from the granite surface, none of these tools are going to do that for you. The only way to know how much radon you have in your house and how much may be coming out of any granite or other stone features you have in your house is to test your indoor air for radon.